Okay, we're going to review binomial distributions, binomial probability. So it is helpful again to have your formula sheet. And on the formula sheet, if you look on here, this formula, you should be familiar how to fill that in because it'll really help especially with multiple choice questions. The mean and the standard deviation probably going to come into play. The mean is n times p. The standard deviation n times p times q, or 1 minus p. Geometric distribution, mean and standard deviation, those are going to come into play. This formula, I usually don't use that formula. I usually, with geometric, use a tree diagram. But let's just kind of jump in. First, a couple things. Make this a little bit bigger if I can. Let's see. That wasn't the right thing. Well, I'm going to leave it because you probably can see it. Bernoulli model has several things. It has a success-failure situation, independent, and a fixed probability. Now, binomial and geometric fall into Bernoulli models, where it's either yes or no, independent, and you have some probability given. But then what's the difference between a binomial and a geometric model? A binomial has a certain number of trials saying, okay, we're going to draw 10 times. A geometric model is when the first success occurs. We're going to see both of those today. Hopefully that rings a bell a little bit. Again, what I'll tell you is if you are studying and there's something you really just didn't get when we went through it the first time, it was a real struggle. Don't spend a lot of time trying to figure that out now. Just realize that everybody has weaknesses on the AP exam. Find your strengths and really know those. Study those. Stuff we've gone through, CUS, FUDs, those are always on there. Linear regression, everybody should be able to do stuff with linear regression. Some of the probability, everybody should know some of the probability. If it's something that you kind of know, then it's worth spending some time on. But hopefully you're all spending about 20 hours maybe on your own looking over your old notes. Hopefully you've kept your notes and looked at some things. Feel free to email me. You can go online. You can find different reviews out there too. I've got enough review stuff in here. I've got a couple other practice multiple choice tests, I think, on there. If I don't have them available, make sure I get them available. But let's jump in. According to YouTube analytics, 30% of stat students are using YouTube as part of their AP exam review. To investigate this claim, they have a random sample of 80 stat students. Show that X is a binomial random variable. Okay, so it's a success and failure situation. Either they use YouTube or not. Now you should write a little bit more than I do. I'm not trying to make this a key. So if you were asked this on the AP exam, you'd say because they either use YouTube or they don't. Independent, one stat student won't affect the next. There's a fixed probability given. It's 30%. Then there is a certain number of trials. They surveyed 80. So that makes it a binomial distribution. If the question was, when does the first success occur? That would be geometric. What is the shape of the distribution? Okay, now this one, I didn't put this down in the other part, but if you take n times p and n times 1 minus p, sometimes we call that q, 80 times 0.3, is 24. That is at least 10 successes. 80 times 0.7 is 56. That's at least 10. So it's nearly normal. We've justified a lot of those with proportions. That's always the justification for nearly normal. If it hadn't been nearly normal, then since this was at 30, the shape would have been skewed right. There would have been more room to move to the right if you calculate the mean and standard deviation. What is the mean and standard deviation? That goes back to these formulas, NP and NP times 1 minus P. So the mean, N times P, is 24. Okay. If we had a normal curve, which we actually do, we could put 24 here. And the standard deviation is the square root of 80 times 0.3 times 0.7. So we'll get that on our calculator here quick. Got a 1/3 hiding in there for some reason. We'll better get that out of there. So 4.1. We'll just call it 4.1. Find the probability the sample has exactly 32 students that use YouTube. This is where this formula would come into play. Now again, probability X equals exactly 32. We have 80 students. We want 32 successes. So we're going to take 0.3 to the 32 times 0.7. And these two have to add up to the 80. So there would have been 48 that don't use YouTube. Now this is a binom PDF. Now it is a PDF. I'm going to do it as a CDF. This is my N, this is my P, this is my lower, and this is my upper. And the reason I'm doing that, with my face-to-face classes this year, I showed them you can always use the CDF, and it gets you the same thing, menu 6.5, binom CDF 80.3, 32, 32. The lower and upper bound being the same. Should be 0.015 if we round it, but if we had gone with the PDF, you notice it would have been the same thing. It doesn't make a difference. You should know this formula because you're going to see that on multiple choice questions. And you're going to have those on some multiple choice questions that if you don't know that formula, it could cost you. That's a formula everybody should be able to remember at least a little bit. But if you do this on the AP exam on the written part and you put binom PDF or CDF, make sure you label those things. And if you're using the CDF, make sure you say something like these are the same if you use the CDF. Find the probability at least 32 are using YouTube. Now I'm going to actually do this one the long way. Probability X is greater than or equal to 32. So that would be the 32 that we got here before, plus, and then it would add all those in between up to 80 out of 80. And that's what a CDF actually does. Now, if you're using the TI-84, you a lot of times have to do these a little bit differently. You have to do things where you have to subtract them and stuff like that. I'm not going to go through all that. Hopefully you know how to do that. So 0.3, we're going to go 32 up to 80. That's our lower bound and our upper bound. And we get 0.036. College Board selected a random sample of 80 AP Stat students and found that 32 of them were using YouTube. Does it provide convincing evidence that more than 30% are using YouTube? Okay, so whether we get 32 or more, that p-value, 0.036, they found it that it's 32. So remember, this is the idea of like if you take out your wallet and you open it up and I say, well, do you have $5? If you have more than that, if you have 10, you have $5. If you have 4, you don't have $5. So really the 32 or more is what we should use, but that's less than 5%. So is it convincing evidence? It's yes. I mean, we would reject the no since it is more than that, over 30% are using it. We could write a null that P equals 30%. And the alternative P is greater, we'd reject the null and we'd say, yeah, it is evidence of that. All right, number 7. Now they change it to 40%, but we don't have the 80 anymore. Okay, and it says she's going to pick the students one at a time until, or he is, Mr. Wilcox, until he finds a YouTuber. So again, now remember, I'm not trying to make this a key. You have to listen to what I say. So if you were doing this on the AP exam, it's success and failure. They either use YouTube or they don't. Independent, one student wouldn't affect the next. There's a given probability, it's 40%. And to make it geometric, it has to be, we're doing something about when we find the first success. All right. What is the shape of the distribution of y? Okay. So this one, we don't have a given formula. So we're going to look at the mean and we're going to look at the standard deviation. Okay, so our mean is 1 over p. So 1 divided by 0.4 gets us 2.5. And the standard deviation of a geometric distribution is the square root of 1 minus 0.4 over 0.4, and it's 1.93. Now let's think about this. 2.5 for the mean and 1.93. If you start drawing this thing and you try to make a normal curve, 2 draws, let's just call this 2 for simplicity, half a draw, -1.5, you can't draw a negative amount of times. So you would explain that it would cut off, the shortest you actually can find a YouTuber is actually on the first draw. You can't even go below 1, and you could find a YouTuber on the 3rd, 4th, 5th draw, so on and so forth, and higher. So we have a lot more room to go to the right. So therefore, it is skewed to the right because you can't have values. You can't even have a 0 value because you can't find it on a 0 draw. First draw is the lowest you can find it. Okay, I already did the mean and the standard deviation, so I'm going to default to that, and we use that in combination. So we'll continue. All right. Find the probability it takes exactly 5 students to find the first YouTuber. So this one, I would go like this. There is the formula here, which is 1 minus p to the x minus 1 times p. I'll show you that I am using the same thing. We would have to not get one, not get one, not get one, not get one, and then get one. So that is the probability of failure to the 4, which is the 1 minus p to the 5 minus 1, that's to the 4, and then times the probability, and that's what we would get. If you were asked this question, now I would put the context down and get that down on there. So 0.6 to the 4 times 0.4, we get about 5% chance we find on the 5th. What's probably it takes at most 5? So it could take 1, 2, 3, 4, 5. All right, now this one, you can do it with a lot of formula, but I would do it as a geometric CDF. We could find it on the 1st to the 5th. I think actually the probability has to come first, so I'm going to have to squeeze that in there. Probability, lower, upper. So the geometric CDF adds up the probability that on the 1, 2, 3, 4, or 5 times. So we're going to go menu, 6, 5, geometric CDF, 0.4, 1 to 5. We should get about 92% chance we should find it in that range. Suppose it takes Mr. Wilcox students to find the first YouTuber. Sorry, covering up a number. 6 to find it. Does it provide convincing evidence that less than 40%? Okay, so if it took 6, that would happen. We'd have to not get it, not get it, not get it, not get it, not get it 5 times, and then get the YouTuber on the 6th. So we'll take 0.6 to the 5th times 0.4, and that would give us a 3% chance. Since 3% is less than 5%, this is rare. Now think of it like a hypothesis test. The null would be that it is 40, and the alternative is that it's less than 40. You wouldn't have to write this, but this is rare. We would reject the null. We believe it is less than, what just happened? There we go. Less than 40, since it is unlikely to happen by natural sampling variation. The p-value is all about natural sampling variation. Anything less than 5%, we usually think that's pretty rare. So hopefully that reminds you of binomial and geometric, and thanks for watching the video. Study hard.